Okay, so now we're going to look at nonlinear relationships. And the difficult thing about this is you're going to have all kinds of options for an equation. The thing you need to look for is exponents. Okay? So if you have y equals x to the second involved in there, or y equals x to the third, or you could even have this. You could have x as an exponent. If you have something like that, that's going to be a nonlinear relationship. Now, as a table, you still look at your slope. My y change is an increase of 2. My y change here is an increase of 6. And my y change is an increase of 10 here. Now, I'm not going to go ahead and make a snap judgment and say that that's nonlinear, because up here, I had different y changes and different y changes. But after I found my x changes and made them into ratios, they all simplified to the same thing. So that makes it a linear relationship. Down here, I found my y changes. Now my x change is 1, 1, and 1. So when I write my ratios, 2 over 1, 6 over 1, and 10 over 1, those don't simplify to the same thing. I've got 2, 6, and 10 as my rates of change, and that's not going to work. Okay, right here, because I have different things, this is a nonlinear relationship. Okay, so that's what it's going to look like on a table. On a graph, similar to your equations, you've got all kinds of options. If you have an x squared, it's going to look like that. If you have an absolute value, it's going to look like a v. So I'll put that over here too for your equation. If you have absolute value of x, that's going to give you a nonlinear relationship. X cubed looks something like that. That's x cubed. All kinds of options there. Basically, it's easy to tell in a graph because it's anything that's not a straight line. Now, as far as situations go, growth charts. You guys go to the doctor. You've gone to the doctor maybe once a year since you've been born, maybe sometimes more than that. So the growth of a child is not a linear relationship, because in the first year of your life, this is example 1, first year, you are expected to triple your weight, your birth weight. So let's say you were 6 pounds when you were born. By the time you're a year old, you're expected to be somewhere around 18 pounds. However, we do not continue on that path, because by the time you were 2, you'd be expected to be 36 pounds. And then, nope, just kidding, that's not times 3, that's just double. Anyway, whatever 18 times 3 is, that would be 54, okay? Then you triple that again. This is not a linear experience here, okay? Because we do not continue tripling our birth weight. If we did, we'd be ginormous, okay? Now, bacteria, if you've ever seen bacteria grow, that is not linear either. That's exponential. You may start off with 1 or 2 bacterial cells, and then they grow exponentially, okay? So their growth would look something like that. Suddenly it just skyrockets, Okay, so that's bacteria growth, and that is not a situation that grows in a linear form. Now here, my sequence is I'm multiplying by 2 each time. That's going to give you a nonlinear relationship here. From here to here, I'm squaring 1. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. That's not a linear sequence. Here, I'm subtracting 5. I'm subtracting 10. I'm subtracting 15. I'm subtracting 20. Not moving the same amount each time by addition or subtraction. That's nonlinear sequence. Here, I'm adding the previous term. So 1, and then 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. So again, I'm not adding or subtracting the same thing each time. So that's not a linear sequence. That's what we have for nonlinear relationships. Stay tuned for inversely proportional.